do you see a world where, like, in your sense, in your own work and just in the space industry in general, do you see that people are moving towards bigger satellites or smaller satellites? Is there going to be a mix? Like, what are we talking? What does it mean for a satellite to be big and what's and small? What size
So
that we're talking about?
big, the space industry prior to, I don't know, 1990, I guess the majority of satellites were the size of a school bus and cost
Wow.
a couple $1 billion. And now, our first launches were on satellites the size of shoe boxes that were built by high school students. So that's a very different, to give you the two ends of the spectrum. Big satellites I think they're here to stay, at least as far as I can see into the future, for things like broadcasting. You want to be able to, broadcast to as many people as possible. You also can't just go to small satellites and say Moore's law for things like optics. So if you have an aperture on your satellite, that doesn't follow Moore's law. That's different. So it's always going to be the size it will be, unless there's some new physics that comes out that I'm not aware of. But if you need a resolution and you're at an altitude, that kind of sets the size of your telescope. But because of Moore's law, we are able to do a lot more with smaller packages, and with that, comes more affordability and opening up access to space to more and more people.
Well, what's the smallest satellite you've seen go up there? Like, what are the smallest kind? You said shoe boxes.
Yeah, so I think the smallest common form factor can fit a softball inside.
Wow.
So that's 10 centimeters on each side.
So cool.
But then there are some companies working on, fractions of that even. And they're doing things like IoT type application. So it's very low, bandwidth type things, but they're finding some niches for those.
Do you mean like there's a thing to do with them?
Yes.
Like, what do you do with a small satellite like that?
You can, track a ship going across the ocean. If you're just pinging something, you can handle that amount of data, and
so
those latencies and so on.
You have to have propulsion on that. You have to have a little engine.
No, those are just, letting fall out of the sky.
Okay.
Yeah.
But what kind of satellites would you equip a colloid engine on?
Anything that's bigger than probably about 20 kilograms, anything that needs to stay up for more than a year, or anything somebody spent more than like $100K to build are kind of the ways I would think about it.
That's a lot of use cases. What's a small sat? Like what
small
category?
Small sat's actually very big. I think it's like 700 kilograms, or I keep hitting my microphone. Maybe 1,000 kilograms down to 200 kilograms, or people have their own kind of definitions of how they break them up. But small sat is still quite large, and then it's kind of also applied as a blanket term for anything that's not a school bus size satellite. So, we need to get our jargon straight in the industry.
So what do you see a possible future where there's a few thousand satellites up there now, a couple thousand of them functioning? Do you see a future where there's like millions of satellites up in orbit? Or forget millions, tens of thousands, which just seems like where the natural trajectory of the way things are going now is going.
Tens of thousands, yes. The two, buckets of applications, one is imaging and the other is communication. So imaging, I think that will plateau because one satellite or one constellation can take an image or a video and sell it to, infinity customers. But if you're providing communications like broadband internet or satellite cell or something like that, satellite phone, you're limited by your transponders and so on. So to serve more people, you actually need more satellites, and perhaps at the rate, our data consumption and things are going these days, I can see tens of thousands of satellites.